Hey guys, welcome back to another stream. So this one's called Factor Investing. I'm working on a project right now that is I guess you could say, soft introduction into the idea of creating factors for different quantitative models, and it's gonna dive right into it. So I think what we need to do is, let me open folder UMD and also 402. Okay. Let's try running all, see what happens. But there's a few things I need to get done. It died. Okay. What happened? Oh, okay. Maybe this. So, I want to create a datetime object. So let's see how to create datetime object. Python. NumPy. Also, Oh, okay. So I have to pass in a string. I see. Let's try this. Alright, nice. I think this is... Alright, I think this is what we want. Oh, okay. So maybe I need a leading zero. A 1, a 1. Makes sense. Alright, nice. Okay. Oh man, okay. I think I might have left my cord at home, so I can't actually connect my second desktop, which kind of sucks, but that's okay. So I want to take this, and what I want to do is, so we have this data frame, and the data frame itself is organized by, or it's not organized, but it does have the date at which some metric, in this case it's the EDF, I think it's the expected default frequency. So it's reported every month, and I want to be able to group these elements by... Okay, so I think what we could do then is we can group the elements, group this data frame by the occur date, and then after we group the elements by the occur date, we'll apply, I think there's a qcut function that we could use that will then turn these into deciles. Okay, so let's try this. Deciles is equal to EDF dot group by, and then we'll do occur dot. Okay, so we get occur dot, and then maybe we dot apply. Maybe look up what qcuts Python. Okay, so I think what we could do is maybe we'll do lambda x so we can use a lambda function. I think the x represents, in this case, the groups, and so I think we want to group the let's see. So print x. I wonder if this will work. Okay, so I think this is what we wanted, right? So we have each individual group. Now, I think maybe we could add a percentile is equal to x, lambda x percentile. Okay, so oh, right. Let me try this. So we have x dot let's do mp.qcut, and then we'll pass in x return no, let's do edf, and then q number of quantiles. So let's just do this. So 10, and let's print out what this will look like. Oops, shit. So apparently this doesn't exist. Oh, pandas. So pd.qcut. So I guess we have bins, negative. So you have 1, 2, 3, 4 bins. Kind of curious what that is. Oops. Okay, so we have this qcut. Let's see. How to apply qcuts onto Python to find deciles. Alright, I wonder if there's a mp.percentile. What did I do here? So oh, I see. Okay, let's try this again. So I want to see what this is. Actually, okay, wait. So let's print type deciles. Wait, is this a series? Okay. Alright, what if we grab the very first thing in our series? I think we can use iLock, right? Wait, what about this? Okay, so what does qcut return then? Or categorical or series or array of integers if label is false. Alright, let's try this actually. Labels is equal to false. Okay. So what if we print deciles now? What does this look like?
There's a big decision about long term variability. Yes, exactly.
Okay. What is this though? Is it unnamed 0? Or is it something else? Could be this, actually. Okay, then if we were to merge, so maybe we can merge this then, edf df. So pd dot merge. So edf df percentile is equal to pd dot merge edf df. And then we'll do deciles. Let's try to see. So how is equal to inner, and then left index is equal to true, and then right's on. Ooh, okay, so if this is a series, so print type deciles. Alright, dot index. I feel like this might be a multi-index series. So if we want to, I don't know how this works actually, so I'm gonna have to, how to merge data frame and multi-index series. Let's see. How to rename index then? So, how to rename index pandas. It's equal to EDF, DF dot sets index. Let's say ID maybe. Nope. Okay, wait. Dot index. Index dot name is equal to ID. I don't know. Does this work? Nice. Okay, so take the ID. Let's try if we can do this. So right on, do ID, and then display DF percentile. Okay. So I think this is referring to the percentiles here. Okay. All right. So we have them merged. Okay, and then I think we probably then want to rename this. So I think print deciles. So the index is called that. Dot columns? Does that even exist? Okay, yeah, has no. How to label series pandas.
So that allocation is gonna affect how the department runs. There will be administration.
So is it possible to label series pandas? Okay, my index. That's okay. So I think I can rechange the name to edfy is equal to dot rename column. Columns. Wait a minute. I think we could do this. Pass in edfy, and then pass in decile. In place is equal to true. So let's see. Okay, nice. All right. So we have our data frame now with the deciles labeled. Okay, so find the mean returns of each portfolio in each month. Repeat this process from January. Okay. So I'm thinking what this is asking is we're going to actually let me double check here. Okay. Okay, so we can then group by the deciles. Maybe we can melt actually. Oops. Goodbye, Disney. So the mean returns of each portfolio in each month. Right.
نه یعنی خود کاسکو پس داد نوشته بود که هر کی اصلا داره بیاد پس بده بعد اونا گفتن که ما خوردیم مثلا امیل
Can we have 2 group buys?
الان نوشته رفته هرچی لبزه رو حتی استفاده نکردیم جاهور شد و اینا رو کردش تو مشتبه بود به ریفاندش دادن برای که ریفاند داشت که بلندر خوب نیست آتیش سوزی مثلا مثل لباس حتی یه لباس مثلا شورت بپوشین میتونی برید اصلا
Resample. I don't think resample would help here, right? Yeah, no, I don't think so. So maybe we can group by this again. Display that group by. Let's do cur dat, and then drop. Oh, had to remove index from data frame. Let me see. So, change. How to drop index from multi-index. Okay. Okay, so there's that. And then so I think that's fuck. EDF percentile dot index is equal to dot drop level. Call this cur dat. Okay, wait. Oh, dot index. Dot drop level. Let's see. There we go. There we go. Dot group by decile. Okay. Is it possible to group by multiple things? Let's say if we pass in. Oh, it has to be a scalar. So dot apply lambda x, then x stack group by what's it called? Percentile. Oh. Percentile, and then we'll dot mean this. Dot mean. Yeah, it's decile, not percentile. Alright. Whoa, okay. Let's see. How to take mean of specific column in pandas. Let's x. This is perfect, actually. Okay, so mean returns.
That's not the customer service, you call the store.
Display mean returns. Okay, it's good.
No, they did. My fish comes from like 5 times on the phone.
Okay, so this is make a table to report the alphas and betas and their p-values. Okay, so what are we actually supposed to do here? So we use this as a factor, and okay, so sorry, we don't use this as a factor. This is our target return that we're trying to explain using the capital asset pricing model. So each of these deciles then are kind of like, what do you call them? These are time series returns for different portfolios, and I believe the highest decile we could do deciles is equal to deciles plus 1. I think that should be able to add so that, alright, here we go. So we have now 10. Yeah, so these are returns for a single portfolio, and then I think what this is asking us is if we were to run the CAPM regression, so I think right. So one question I have is, do we need to subtract the excess return on our portfolio? Not entirely sure, but let's try this. Okay, so I think what we'll do here is we're gonna have to run a regression for, let's just try a single one first. So let's try mean returns dot block. So we'll get everything from the rows, but we're gonna want 1. All right. Let's just do 1. Actually, it could be this. There we go. All right. So we have x is equal to sm that add constants. All right, and then y is equal to all right. We might want to so I think what I might want to do is we have our what's this? Okay. Oh, that's the industry. Pharma French research factor, EDF. I think maybe Pharma French research factor. Copy relative path. So pd.read CSV. Just passed in. So pd df display df. Okay, so market minus risk free. That's perfect. All right. Alright, I am going to need to somehow turn this into little date-time objects or date-time type. But we'll call these academic factors. I'll call them that. Academic factors. And then we'll call this a df. Alright. So I think I have some code here that I just copy and paste. Yeah, just copy and paste this, and then so that's some pre-processing. I think I'm gonna have to add one more step here, and that's to just set this equal to, actually no, I don't need to. I think use what was the function called? Index call is equal to month. So let's try this. Display academic factors df. Alright, nice. Okay, so market risk premium df. We'll call this, and this is equal to, actually it's maybe a series, right? We'll do academic factors df dot lock. We'll pass in everything, and then we want to use that. I wonder what type this is actually. Type market risk premium. Okay, and then I'll do this. So it's a series. Okay, I'm getting an error. Yeah. Alright, so we have a series. It's good. Okay, so this is where we can run our regression, I think. I think we do model is equal to sm.ols. And then we have our, man, they use ndog and xgog. I think this is just dependent and independent variable. Results is equal to model.fits. And then we can maybe print results stats summary. Alright. So it's saying that these are not the same, and maybe the reason is because I have to select a certain point in time. Okay. So let's maybe go from, so, oh, okay, this one also goes pretty when do we start here? Alright.
Like for me to check to see, because I ordered it in the store.
1990. Oh,
I didn't go online, or I got it through the
okay, we go from here. This actually might not be the best. Okay, so here's the latest we can go. We can go latest December 2018. Okay, so I think that's what I'm gonna go for both here. All right, market risk premium. Nice. So we have negative alpha, which isn't a good sign, I don't think, because we would want the standard.
Wait, can you repeat that?
All right, let me try doing this. So for column in mean returns dot column. All right, so we're gonna do this every single time. All right, and then we'll print out the column.
Yes, because I don't have the button number.
Okay, and then once we pass in the column, do this. All right, well, that did not do anything. Wait, dot columns. Oh, okay, here we go. All right. Okay, so surprisingly enough,
Yes.
our highest decile.
Yes.
Okay. That relationship doesn't really seem like it's supposed to be likely that we have a positive alpha for. Maybe you have to double check what the higher decile represents. I would think that the higher decile represents the companies that have.
Yeah, can you send it to the email? Yes, please send it to me.
I would think the higher decile means that you have a.
When you send it.
Okay, this might be kind of off.
I haven't received it yet.
0.3 is less than 0.7. 1.2 is greater than 0.7 and greater than 0.03. So I think it wouldn't make any sense for this decile to be in 4. Okay, I think I did something wrong with the decile stuff that might be causing this error to happen.
I'm sorry.
So I might to come back to this. Gonna go use the bathroom real quick.
Yes. So I just click this 1 second.
Alright. Let's just see something real quick. How's the stream going? Alright. Not too bad, not too bad. Shit. Spill everywhere.
So you see it 481, right? Okay. Can you repeat that number? I want to make sure you got it. Perfect, okay. So now now this item has been shipped, so will the new shipping label have my apartment number or, not?
Let me see.
Right.
Alright, I'll be back.
I don't see anything movement, so it says pre-shipment label, so. Got it. So what about the shipping address on the box? Yeah. Okay, so when the package ships, it will ship, like the shipping will have my apartment number, right? And you're 100% sure? Okay, perfect. Thank you so much for all your help. And you said it should take 5 to 7 business days, right? Okay, perfect. Okay, perfect. Got it. Okay, sounds good. Thank you so much. Yes. Good. Yeah. Yeah, you deserve 100 stars. Yeah. Okay, you too. Bye. She was very helpful.
I hate the daytime.
You know what we were so.
Okay, so made it back. Oops. Hair's kind of crazy. Alright, so let's see what we can do here. So, okay, I want to see if we have the same number of. So it's the same number of rows, which is good. Excuse me. But okay. All right, let's do this then. So let's take head 50. Oh, I see. Okay. Dot group by curdat dot head. Wait a minute. This doesn't seem right. If we were to group by that, wouldn't it come on this side? So why? Dot head. What are the differences here? It seems like there is no difference, which is weird. Because dot group by cur dat. That's dot count. Do this. By current dates. Wait, dot apply. So maybe you can do lambda x. So print x. Oops. So let's try this. Sort values decile. Mean returns. So the total mean returns EDF dot mean. Display total mean returns.
I mean, up and down. Yeah. My hand's broken.
Oh wait. So decile 1 does have, okay. Oh, wait. I think the reason why I did this wrong is because I gotta do this. I gotta switch these over. Yeah, I think, okay. So, Market Premium. Yeah, this makes sense. This makes sense. Right, I had to swap the two. Okay, okay. So make plots. Okay. Alright. So let's try doing this then. We have model.results dot, I think X will give us results dot, I'm not entirely sure. Maybe print results. What if we just do this? Okay, it's a wrapper object. Maybe there's an attributes. I wonder what this does. Dot underscore gets attributes. What if we did coefficients? Okay, I'm not entirely sure. I forgot what the function was. Okay, how do I get coefficients if corresponding p-values using stats model OS? Oh, it's params. Okay. Coefficients is equal to results dot params, and then p-values is equal to results dot p-values. Okay. Coefficients is equal to is equal to, and then we have p-values is equal to blank.
Even the current one that they have on that floor.
Okay, so alpha is equal to blank, beta is equal to empty, and then p-value. So maybe alpha p-value, and then beta p-value, right? Alright, so let's do alpha dot append coefficients. So 1 beta 0. Okay, I think this is what we could do. 1. Alright, nice. And then we could display, so df is equal to pd.dataframe. And then we'll pass in dictionary. So maybe alpha. And then pass in alpha. And then beta, alpha p-values, alpha p-value, then beta p-value, okay. So let's do summary capm summary df. Alright, display capm summary df. Alright, that seems pretty standard. I think what we want to do is maybe index is equal to actually index name. How do I name the index of data frame when using pd.dataframe? Is it possible to make the index start from 1? Okay, so nice. Index is equal to mp.arange, do 1 through 11, and then name is equal to decile. Alright. Okay, so let's see. Unexpected word name. That's great. ChatGPT lied to me. Okay, so let's see if this works though. Okay, and then index name is equal. Decile. Okay, dot index dot name. Nice, okay. So that's good. Don't need this. Okay, so we have capm. I wonder if we could capm summary.df.plots. Probably need a. Okay, wait, alpha. Wait, I forgot what we need to put in the data frame, but let's try this. So fig x is equal to plt.subplots, and then we'll do 2 by 2 fig size. It's equal to, we'll make this, let's say 12 by 8. Might be too big actually. Let's see. There's no hyphen. All right. Yeah, that looks reasonable. It's a bit compressed, but okay, I'll take it for now. All right. So let's try to plot. Okay, data frame plot. X label. Okay. Probably going to need. Kind is equal to, oh, no. I want to do y is equal to alpha. And x is equal to x. Call this 0, 0. Let's see. All right. Nice. Okay, so we have beta, and then also, alright. X 0, 1. Okay. And then mean returns. Let's do, okay, maybe 1, 2. Probably is gonna be good. Zero, 1. Yeah, this shit's way too fat. Alright, let's, maybe 5 is better. Okay, that's good. And then maybe mean returns. Let me first clean this up a little bit actually. So x0 dot set title. So we'll call this alpha. Beta.
Thank you so much.
Okay, so alpha per decile. So capum alpha. Okay. Then x0 dot set y label. Call this alpha. Beta. Alright, nice. Okay, mean returns. So if we want to take the mean returns, I think we would probably, what do we want here? Okay, so we want total mean returns. All right. Let's do 3 actually then. And maybe 4. Three. Plots. So x2 dot plots x total mean return. Let's see. Ooh. Okay, that's a bit rough. All right. Yeah, let's make this 2, this 5 again. Alright. So, fig x is equal to PLT dot subplots. Alright, and then x, plot mean returns, PLT dot, shoot. How to combine a 2 plot graph and 1 plot graph matplotlib. Is there a matplotlib function to reduce white space between different graphs? Wait, what does np.squeeze do? PLT dot type. Okay, what does PLT dot type layouts do? Okay. Let's see. All right, let's just see if we can actually do this. X2 dot plots. Okay, it's kind of not really. Still kind of looks kind of ugly. We have 14. 16. 20. Okay, wait. 16. Okay, and then let's label this so x2 dot. Mean returns. Decile mean returns. Let's see. Oof, yeah, this is rough. All right. Mean monthly returns. Monthly mean returns. Maybe we could fix the layout another time, but I think this is a pretty good start for now. So make a figure plots these average monthly returns against the returns. Getting distracted real quick just to check if I'm gonna check if something ended up getting passed yet. Okay, nothing. Alright. So plot these average monthly returns against the returns predicted / implied by the CAPM and add a 45-degree line. So you did in assignment 4. Okay. So we have the alphas and the betas. I think then what we could do is CAPM summary DF. We could take CAPM predicted value. Okay, so CAPM predicted returns is equal to CAPM summary. So average monthly access returns. Access returns is equal to okay, I think this is Markers premium that mean. Beta times average monthly access returns. Okay. So fig x is equal to CAPM summary DF. Actually, no, sorry. PLT.subplots, and then we'll just input nothing for now, and then we hit plots. Actually, probably do CAPM summary DF dot plots, and then we'll plot the CAPM predicted return. Then just stick that into our axis. That set title is CAPM predicted return. So that sets label y label. Okay. Alright, so this one we'll just do predicted actually return monthly return. I think it's average monthly return.
So you may have noticed there are magnets inside of that. That's because this one has yet to be finished. Sanded to find the space. Afterwards, I'll have like another one. What do I do with it? I don't know. At this point, it's like more like a wood collection.
Okay, so let's just see what this looks like. Y. cap M predicted returns, so it's relatively linear. And then I think the average returns, so X that plots. Total mean returns, that's what we want. PLT dot sites layout. Let's see if this does anything. Okay. X dot plots. So we have 0, 10, and then, oops, feel my computer lagging. Let's see. Whoa, okay. I think maybe what we could do then is set the X limit. Set X limits. Actually, we don't really need X limit. So let's say 0.5. Actually 0.5. I think that should. Sets Y lim. Wait a minute. Oh, bottom is equal to negative 0.1. Top is equal to 0.5. Let's see. Whoa, right. It's 0.1. Let's see. Even then, alright, 0.05. Negative 0.05. .02. Okay, so we do need a XLM actually. Bottom is equal to 1, top is equal to 10. Oops, XLM. Is it left is equal to 1? Right. There we go. Hmm, 1 to 10, maybe 0 to 9. slope is 1, right? Oh, I see. Okay. So the plot itself, I think on the x-axis, it's okay. I think. Alright, we're going to need to do this actually, so x. Maybe we can also add this. So mean returns is equal to total mean returns. Alright. X. Okay, mean returns. I think we could do this actually. Oh shoot, mean return. Nice, alright. I see. Plots 0, 1. X dot set xlim. So this will be from 0.0055 0.0085. Alright, and then whoops. So this is right is equal to left is equal to, and then we have right is equal to, oops. Alright. Okay. Then we could set the y-lim. So bottom is equal to, we'll have negative point 0.025 up is equal to 0.02. Alright. Shit. Oh. Top? A2 maybe? Alright. Actually 0.0055 1
Yeah.
Oh, wait. Okay, so 0.0055. Okay, I want to think about this, the 45-degree line. I gotta use the bathroom again, so I'll be back. Okay, yeah, I just realized, I think for the 45-degree line, you could just do rise over run. So, rise will be 1 minus 0.0055, or sorry, yeah, and this would be to 1 minus 0.055, 45-degree line. Okay, so this is the 45-degree line that represents the CAPM. This is kind of the scaling. Oh, wait. I think actually we probably want this. Oh, okay, that is the case. All right. All right, sorry. I think I got confused here, but at the end of the day, this should exactly be equal to this. So 0.055 is exactly equal to 0.0055 here. Alright. Okay, so that's good. Got all this part done. Now okay, the scatter plots. So kind is equal to scatter. Color is equal to, let's say, orange. Alright, nice. Okay, alright. Oh shoot. So same thing, we have to run the Fama French this time. So this might be a little bit more sophisticated. Alright. Point one, let's see. How does, okay, so it's A. B. Make your figure points. Okay, so it's same idea here. Discuss your results. D. Alright. So I might just get the coding portion done here, and then later stream I might try to go over the economics of everything. So make a table to report alphas, loadings, coefficient of the SMB, and HML factors and their p-values. Okay. So I think what I can do here is copy and paste this code. Actually, is this the, yeah. Okay, so marker is premium. Alright, so marker is premium, and then we also have the small minus big. So B, then high minus low, and then HML. So maybe pass in a list, marker is premium, small minus big, and then high minus low. this is the, we'll call this markets beta, and then SMB beta, and then also the HML beta. All right. Market p-value to SMB p-value, then HML p-value. Okay. Okay. So dot append. Alright, nice. So we have, oops, coefficients. I think we could do 1, 2, 3. Alright. Oops. So p-values. Okay. And then maybe we'll do FF3 summary EF. Okay, so this is where it might get complicated. Alright, so let's do FF3 dict is equal to, it's alpha, alright. SMB loading. Okay, so alpha p-value, and we have market p-value, and then we have SMB p-value, and then HML p-value. Alright, nice. And then instead of this, just pass in that's, alright. Yeah, I wonder, what happens if we do this? Can I not do multivariate regression? So multivariate regression using stats model. Okay. I see. X is equal to constant X see. Matrices are different sizes. Oops. Print Y, so print X, print Y. Let's do print length of X 0. 349. 348. So why am I getting an error that matrices don't fit? This might be fucking it up. No, it's still the case. Oops, what did I do? 2. Zero. So MP dot array. So X dot size.
You know the street is, Campus Street is.
Maybe shape actually.
So this is.
334. Okay.
Paintbrush is big and it flows it. And that's why the building is where it goes.
So maybe X dot transpose. X dot transpose. Transpose. This
You know
is
the,
X
second
dot
floor?
add constants.
The second floor is.
Add constants. X. Nice, there we go. Alright. Checking my email for check if my team moved on to the next round of this datathon thing. Nothing so far, so probably means that we did not. Yeah. Alright. Okay. So we have the deciles, nice. Market loading, SMB loading, mean returns. so I think this, I can just straight up copy this one again, except this time I'll do 2 by 3. Okay, and then I think I could set this, so 0, 0, and then 0, 1, 0, 1, 0, 2, 0, 2. So market's loading. So market loading. Set Y label. Beta. Call this SMB loading. Alright. HTML loading. Beta. So Y is going to be equal to market loading, SMB loading, HTML loading. Okay. Oops. X 0, 0, 0, 0. What the hell? Oh, okay, we gotta do this. F3. Mm. 1, 1, 2, 2. Alright. 2. Nice. Set title. Nice. Alright. Small minus big. So it seems like the small companies, high minus low. Big companies with low book to market ratios? Maybe. Alright. Okay. Need the alpha. One, two. Alpha. Mean return. Monthly return. Okay. Okay, and then I think we could just do this. Market loading, we will do alpha. This one will do mean returns. Okay. So this, I think we just copy straight up again from this one. All right. So we have average monthly access return, and then average monthly HML is equal to, call this small minus big. What's it called? Wait. Average monthly SMB. High minus low. Dot mean. FF3 predicted return is equal to call this markets loading plus FF3 summary DF. Call this SMB loading times small minus average monthly small minus big. Plus 3 summary DF, and then we do the HML loading. Okay, and then we multiply that by the average monthly HML. Oh man, I spelled that wrong too. Oh, meant. Yeah, there we go. Alright. So we have the average monthly. Okay, so this should give us our predicted return. Alright, so let's do Fama French 3-factor predicted return, monthly returns. F3 predicted return, kind scatter. Alright. Let's see what's going on here. Oops. Okay. Nice. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So FF3 predicted returns around the same actually. Okay, last decile is a bit higher. Point 0.95 maybe. Okay, nice. So I think that's good for now. Probably gonna call this. Yeah, probably gonna end the stream here. My mind kind of hurts from doing all this stuff, so gonna take a break. Probably go get some dinner at the dining hall. But thanks for tuning in, and was able to build out Factor and then be able to see how well this Factor performs against different types of, I guess, benchmarks. One being the CAPM, the second being the Fama-French 3-factor model. And turns out that the lower decile, or the firms with lower default risk, actually have a higher return compared to firms with higher default risk. And this kind of goes against the idea of Fama-French 3-factor model. And then also the CAPM, because usually the return on a company scales positively with the increase in risk of a company, but in this case we can see that as the risk increases, the returns also as the risk increases, the returns decrease. So that's interesting to think about. I think maybe when we talk about the economic behind it, that's when we can maybe use some intuition and also some outside research to help. But with that, probably going to end the stream here. Thanks for tuning in, and have a nice day. I'll see ya.